The title of the talk is Rigorous Testing Automated Push Button Approaches. So we focus on unit testing, software testing, and push button refers to automation, that we try to automate unit testing. Yeah, so my giant female is Anna Makai, a musician and activist from Budapest, a good friend as well. And she is not only doing very nice music that you can check out on her Bandcamp page. She is also engaged in very important and wonderful projects where she teaches children to make music, and children also from minorities in Budapest, the Roma minority notably, which is a very, very important thing to do in this city. So she is definitely an inspiration for me, and like I said, her music is special. Do check it out if you're interested. A quick intro on the company where I work, Inquiry Labs. By the way, I'm joined by a colleague, at least one colleague, Daniel, and I was supposed to be joined by another colleague, Balint, who got sick, unfortunately. So he couldn't be here. And they are members of the Insta Coverage team, which is one of our products. So let's go back a little bit. So Inquiry Labs is a software company founded in 2012. It's based in Budapest. We do services. We have a big network. We do R&D. We have a very good connection to the university. Colleagues have a university, like a research background, and they teach in various universities in Budapest and in other places. We do have products as well. So one of our products is Insta Coverage, which you can check out on the product page. Insta Coverage is basically an advanced unit testing tool for Labview and Labview NXG. So that's a short introduction. And now let's come to the topic of the talk, unit testing. So this is a very basic introduction to the topic. So basically you have a piece of code, which is black box, but you know the specification of this black box. So if this black box is an adder, a calculator, then you can trigger this black box on the inputs. For example, 5 plus 2, it's supposed to be 7. In this case, the test is passed. For 6, it will be failed. And the test case is, one test case is the set of inputs for one execution. So we see 2 test cases in this example. So this is clear. Or should be. So unit testing is the good friend of any software engineer. Now, what are the challenges of unit testing? You may know this totally random made up Labview example of mine, which I've been using in the future in various NI conferences. The bottom line or the message of this example is that we have a critical VI, which is placed somewhere in the code, and it is not trivial, or it may not be trivial to reach this critical VI, but this is critical. So the VI is critical, so it should be important to test it. So one challenge is that to write a test for the critical VI in this example, and this is used to be a manual process. We all know it. So it's a challenge for the programmer. And another, so the programmer thinks to trigger the critical VI, but a challenge is to check if it's actually the case that the critical VI is executed. So there are ways in the Labview ecosystem to automate this check through coverage measurement, and there are tools to measure coverage. So this is a done challenge, I would say. Another challenge is which is much more ambitious, and this is what my talk is about today, is to automatically generate tests for critical, for example. And this is a challenge that is not done yet for the Labview ecosystem. At least I'm not aware of any solution where a tool would automatically generate tests, completely automatically. Now, there is a high-tech approach which is called symbolic execution. It's more or less an established technique, at least that's established for the academia. And there are implementations for actual programming languages, but not for Labview. So basically, symbolic execution is a magic box, and you tell the box, give me inputs so that the critical VI is executed. The symbolic execution engine does the magic and will give you the inputs which will guaranteed to trigger an execution, so a path, an execution path on which the critical VI is executed. And this may be, in this example, let's say that if we go through the second case, which we don't see on the picture, and we have an empty class which we can generate through the constructor, and a so a false error input, then we execute the critical VI. Now, if you look into this magic box, then we see two main modules. One is a constraint solver, and one is a symbolic language interpreter. And I will try to explain how this works, how these modules contribute to the working of this magic box. So this is a textbook example of symbolic execution, which is very helpful to understand the very idea behind it. So how this magic box works. So on the left-hand side, on the right-hand side, you see the control flow graph of this example program. So try to ignore the left-hand side yet, which is a bit more involved. So let's first try to understand what this example program is doing. So it basically reads a value from the input and assign it to X, and then it increments X by 5. Then we have a branch on the a value of X. Then we read in another value and assign it to Y. We have another branch on the value of X, and then we have another branch on the value of Y, and we have an end state and an error state. Now, if we flatten out this program, and then we get the other graph on the left-hand side, which is called the symbolic execution tree. And here is the trick. So the symbolic language interpreter does not work on actual values. It assigns variables to variables. It assigns symbols to variables, that is to say. So if you see the blue assignments, you see that instead of reading in a value for X, for example, 7, it assumes that it can be any value, and the symbolic language interpreter calls it A and assigns it to X. And then when there is an operation on X, then the operation is being done based on this symbolic value A and not on the actual value. So in the second step, the value of X will be A plus 1. Seems that
yeah, so the Nest is asking, I think you're still describing as you are going through the branch. You haven't really changed your slide, correct?
no, now I'm changing back and forth.
Yeah.
Can
Okay.
you see it?
So
Yeah,
yeah.
so it's still the same slide with the two graphs. Okay, thanks. So yeah, so this is the blue part, the blue annotation. And if you now, you should be seeing a refreshment. Now, what you see marked the path conditions. So these are so this is an additional job that the symbolic execution, the symbolic language interpreter needs to be doing, is to mark so-called path conditions so that it remembers the decisions made on the symbolic values. So for example, the first branch was a check if x is greater than 0. Now x is a plus y symbolically. So we remember that when we follow this branch, then we had this constraint a plus 5 is greater than 0. And as we reach a leaf, for example, the error state, then we have a bunch of path conditions. And now this is the magic, and this is the very nice use case of symbolic execution. You can ask the symbolic execution engine to generate inputs so that I can reach the error leaf following this path on the left-hand side. Now, and this is where the constraint solver comes into play. The constraint solver is given a set of constraints, which are exactly the set of path conditions that are marked. And since this is a satisfiable constraint set, it will give us an assignment, a satisfying assignment for the values A and B, for example, 0 and 2789. And this will do it, and this will reach the error state in a guaranteed manner. So there is no trying, no random input generation. It's a guaranteed process. Okay. Now you see that we can reach the error state. If you look at the graph on the right hand side, you can see that we can reach this error state in the bottom through two paths. Now, if we ask the constraint solver to generate inputs so that we execute and reach the error state through the other path, it will give us an unsatisfiable answer because, as you see, the constraints are contradicting. For example, the easiest contradiction is the last constraint, which is 10 equals to another constant, which cannot be true. And by the way, the first two constraints are also contradicting. Now, if you think of a path coverage, which basically guarantees that all parts of the software unit under test are exercised and executed, then symbolic execution can give you a guarantee that this is not possible. Okay. So that's it, basically. That's the very idea behind symbolic execution. Is there any question at this point for symbolic execution?
I don't see any questions so far, besides what I mentioned earlier about the slides. So
Okay.
seems clear. They
So
said.
this is, okay, thanks. So this is a very, very powerful approach, and we will, I will have bad news on that, unfortunately. It's powerful, but expensive to implement. So let's be, okay, I can read this one. Yeah, so we will, thanks, Gabriel. We will come back to the performance issue later in the presentation. Very good question. Yeah, so a lower tech approach, but much more feasible, approach is called a random testing with feedback loops. So the very idea of this one is very intuitive, easy, and yet powerful. So basically, you have a loop. This is the outer loop, the bluish loop, and you have in the body of the loop you have the following steps. You generate random inputs. You execute the software unit on the test. You measure the coverage to see if you exercised the software unit and the test to an extent that is acceptable for your application. And you ask yourself, is a threshold reached? A threshold can be a percentage, a coverage percentage, or can be a timeout because you don't want to wait forever. If the answer is yes, then you finish and you are happy because your test generator gave you tests. If not, then you go on. So this is the very idea of random testing. Random testing with feedback loops. If we come back to our running example on the right-hand side, the Labview code snippet, then you see same question. We try to generate inputs so that the critical VI is executed. So as we saw on the previous slide, we do random testing, so we have no idea. It's not like the smart symbolic execution approach. We have no idea how we could reach the critical VI. So we just generate inputs randomly, which could be like this, as case one string, an empty class, and the true error cluster. If you remember, I said that let's assume that this set of inputs would not exercise the critical VI, so would not reach the critical VI. Now the loop goes like this. We check if critical is executed. No, it's not. That's the assumption. And this is the trick. So we mutate the initial test. So the mutation operators can be various. And in this case, let's assume that we are lucky. We apply an iterate mutation. So we basically iterate on the switch case and go from case one to case two. And we also iterate on the Boolean variable, or we flip it. This would be another mutation strategy. And we flip it from true to false, and we go back. We do the check, is critical executed? Yes, we are happy, and we are finished. So we managed to, it's a brute forced random approach. In its heart with some intelligence, which is the coverage measurement, yet powerful, or it can be. It has the potential to be powerful, and you will see that the power of the mightiness of this approach really lies in the richness of the mutation operators and strategies. Yeah, in general, as you may understand already after all this introduction, in general, it works like this. You generate random inputs. You check if your coverage reaches a threshold or there is a timeout. If not, then you mutate the tests and go on. If yes, you finish. Now, an example can be that I have a coverage threshold of 80% because I don't want to cover everything in the software unit and the test. And the timeout would be like 2 minutes because I do it if in 2 minutes the test generator gives me good answers, then I'm happy. Otherwise, I do the job. Yeah, this is genetic. This is another way. Gabriel, another question, another great question. Thanks. Some people call it genetic test generation. Yes. With this approach, do we make sure that we don't repeat inputs? We should. It depends on the implementation. It would be silly and a non-efficient way of implementing this algorithm. Yes.
Generate random inputs, but not repeat it. So generate unique random inputs would be what you're
Yeah,
doing.
you see the generate random inputs. It's the initial step. Then you don't do it anymore. Then you have like
But the random
a
inputs
queue
are all
of
unique.
inputs that you muted.
Right, they're not. Yeah.
Yes, and then you should make sure that while you are mutating the test, you shouldn't trigger the software unit on the test. Let's call it, it's a Labview conference, the VI under test. You shouldn't execute with the same inputs. Yeah. A disclaimer. You may have noticed that we don't. So this approach is not about output comparison. So you really shoot at, you aim at coverage, and what the output of the VI under test is. This approach basically ignores, or is not in the scope of it. So we don't check if it's the error out in this example, if it should be, I don't know, it should have a code inside, it should be true or false. It's really up to the user to do it. So it's out of the scope of this technology or approach. Okay, so I come back for a moment and ask the question again. Is there any unclarities, questions for this one?
Like there's no questions.
Okay, so I go on. So this is now a note on our product that we develop at Inquiry Labs. Insta Coverage is a unit testing tool. So it's basically, let's call it a traditional or a conservative unit testing tool. The user needs to implement the unit tests him or herself. Another question. So here we are not talking about unit testing of critical, we are only its integration within a calling code. Yes. Yes. So if I come back.
So you are exercising the BI. You're not really testing it. You're exercising the different paths.
Exactly. You could be testing the critical VI in isolation using the same approach. In this example, critical VI contributes to the final outcome of this code snippet. So you are basically testing it indirectly. Yes.
I think one discussion that comes frequently is how to test private VIs, and there's two schools of thought, but the one that I favor is you don't test private VIs, because if you are exercising the public VIs, then in theory you should be testing also the private VI.
Absolutely, yeah. It's a big discussion, I know. This is the million-dollar question. Yeah, I wouldn't open this discussion at this point, but I guess your like summary of it, a very short summary, was correct, and I would leave it like this. Thanks. Yeah, so Insta Coverage is a conservative, at least in the scope of this talk, a conservative unit testing tool. But we have a branch, a development branch for it, where we implemented a prototype of the feedback loop-based random test generator. We implemented mutation strategies like bit flips, and the literature calls it non-integers and others. And the good news is it works on dummy examples. So it does converge to the threshold, and we can generate meaningful inputs, fully automated. The reality check is the throughput. Commercial commercial test generators are super fast. They can generate hundreds and thousands of new tests within a second. So our implementation is the best effort implementation yet. We really concentrated on the framework of the test generator, so on implementing the framework and testing if the generation process or so the loop can actually converge. And the throughput of our initial implementation is a sober throughput. It's like 2 new tests per second, but every new test may so if we come back, every new test generates new inputs on all inputs. So it's a rich new test always, but it's still 10 new tests, but still the human tester wouldn't be so fast, but the human tester would be much smarter, I guess, than the random generator. Okay, let me go on. So one note on the coverage measurement. So when we look back on the very idea of random test generation based on feedback loop, we see that in the heart of it, we have to somehow be able to measure coverage. Now, the good news is that InstaCoverage has the foundation for very flexible coverage measurement. Question: what if inputs are strings, pictures, pics, map classes, clusters? Very good question. So you need to, like I said, if I jump back to the, you see here the mutation strategies, you should be very well equipped for different kinds of v-end tests, and the test generator should you know, rotate them, select them, and maybe you can configure the test generator, teaching it to know or configure it by the kind of application that you are testing, so that it can apply the meaningful strategies. So if you read the literature on random testing, then you see for pictures, for example, and compressed files, you find strategies for those applications. So the test generator is project specific. No, it shouldn't be. It would kill the purpose. It should be flexible. But if you give it a hint, then it can be more efficient. If you are in the field of, I don't know, picture processing, then it would be just easy to configure it in that way. Okay, so you're welcome. If I come back to here to this point, so InstaCoverage under the hood has a very flexible coverage measurement engine. And since the last version, 3.2.0, the current version is 3.3.0, which came out yesterday. It's good news for us. It's still in the process of being released by NI. So until yesterday, 3.2.0 was the last version. So it comes with a powerful API. Okay, somebody found the cat. It wasn't that
That's
wasn't
stealthy.
that complicated. Yeah,
And
that's
this
stealthy,
is
yeah.
part of
So
the free version of InstaCoverage, or
no, the API comes in
okay,
the
pro
pro
version.
version. So the core version, the free version, doesn't have the API and doesn't support coverage measurement. Yeah, it's just a highlight of how flexible this API is. Basically, you can configure the API about the scope of the coverage measurement, and here are 3 very common use cases. The first use case is which we call own the own tests. So say you have a foo, a VI, So this is the scope, and you have three tests for it, because three engineers or three programmers work on the same tests. So they directly test the VI in the test. A more complicated use case is the VI coverage all test suites. So you are testing one VI, which is foo. This is the scope, but you have three tests: foo, bar, buzz, and foo test the VI in the test directly, and bar and buzz, they test other VIs, but these VI can call foo as a sub VI, and still we can measure coverage through those tests, and we aggregate the overall coverage. And the killer application is what Fabiola, you were missing this this feature, and this is available since 3.2.0. The project coverage, where you throw in everything, you throw in all your tests, and you throw in all your VIs. Basically, the scope can be the project, and Insta Coverage will measure the overall coverage. Thanks. So another example, just to make this point clearer, you may have three VIs, foo, buzz, and bar, and you have two tests for foo and buzz, and both foo and buzz call bar as a sub VI, and foo exercises, so executes within bar one sub diagram, and this other, the red sub diagram, will not be executed by any of foo or bar or buzz. So when we throw in everything, then we get as a result from the coverage measurement that the project coverage is only 50%, or within the project coverage for this VI bar, which doesn't have a test and a direct test. The coverage is 50% because only one is covered by foo, in this example, through a sub VI call. Yeah, so when we come back to test generation, so this engine, this powerful coverage measurement engine of Insta Coverage, gives us the possibility to build a powerful test generator, because you can, through this like coverage measurement primitive, you can configure the test generator, for example, for flat coverage measurement, where we don't we are not interested in sub VI calls, or also in a recursive coverage measurement, when the test generator will try to generate tests so that sub VIs are also covered. Is it able to cover and test dynamically or recursively called sub VIs? Dynamically, good question. Good question. So we should, it's a tricky question. We can come back to it offline. I don't know what exactly you mean by dynamically. There may be caveats here. We should check it. But in the classical static sub VI call example, we do support it. There might be tricky cases where we do not. We have to discuss it. But for most, yeah, okay. Yeah, it may. Yeah, I understand the question. It may. So the answer may depend on how you open this VI. We can discuss it offline. So this is has been a corner case for us. We didn't have this issue in our commercial testing projects, but a good question. Thanks. Okay, so let's come to the trade-offs and conclusion. So we compared two approaches of automated test generation, symbolic execution and feedback loop. And we compare them based on three aspects: the complexity, efficiency, and performance. So for complexity, symbolic execution is tough. It's really tough. You need an alternative. So basically, you need an additional language interpreter which works on symbols. So this means that you, for Labview, you somehow need to replace the heart of Labview somehow. So this is tricky. Plus, you need a constraint solver. Feedback loops are easier. You still need some code analysis because you need coverage measurement, but it's much more easy than symbolic execution. For efficiency, symbolic execution is clearly more efficient because it doesn't just guess, it really goes to the point through the power of constraint solving. It will really give you the specific test you need. Feedback loops, through strategies, they are not super dumb, but they are guessing. They are not totally random, but they are guessing still. For performance, symbolic execution is performant in the good case. So you have to know, and this is now we come to the theoretical limitations of computer science. So constraint solvers have their limitations. So if the language that, so the logic of the language that, so basically your language will be translated into a mathematical formula, and the constraint solver is working on within a mathematical logic, and it's not always efficient. So these are, if you know these results in computer science, like NP hard problems and undecidability, then you know that in general it's not an easy thing to do. But constraint solvers are very fit nowadays, and they can be very efficient on realistic problems. The performance of feedback loops is, if you assume that the performance of symbolic execution is good, the feedback loop performance is not that good, obviously, because it's guessing and it's like running and tries to hit the sweet spot. The good news is that for feedback loop, for the feedback loop based test generation approach, we do have a prototype, like I said. It's a branch of InstaCoverage that we have internally, I think, for the labs. And we have, big hopes for it. So basically, we really plan to release it at some point and introduce it, and then we can start using it. The community can start using it, but it's still in an early phase. So it's just a prototype. Are there any questions at this point?
So far, there are no questions, but let's give them a couple of seconds there.
Okay. Yeah, so I'm towards the end of my presentation. So these are, I can extend it because I have spare slides, but the test generation part is kind of done. I would like to take the opportunity to introduce the new release, just the highlights of it, of InstaCoverage, which is, like I said, out since yesterday, 3.3.0. So it's just partly because the NXG version is not out yet, and I is still reviewing it. So you can, I can show a quick glimpse on that of the website. Do you see my browser?
See your, you're going into WordPress. That's what we're seeing.
Sorry. Yeah. So now this is the website, InstaCoverage. You can go to download, yeah, product page. No surprise there. So the news are here is that we in the 330 is that we basically did a facelift on the UI side. So our classic Labview version InstaCoverage looks much more this millennium. So it had a 90s touch to it, the previous version. So this makes us happy. It's really a much more refreshing experience to work with InstaCoverage. With the UI, the API, the Jenkins wouldn't care how it looks like, and the API is an API. Other news are that we updated the NXG version for the latest NXG platform, which is 5.0. And a very nice feature is that the conversion utility is also extended with the InstaCoverage, so that you have a bridge across the classic version and the NXG version. The NXG version is not out yet, like I said, so you cannot use this feature yet. I guess in the next couple of days, and I will release it, and then the whole package, the 330 is out. But for classic InstaCoverage, so for classic Labview, InstaCoverage 330 is out and available. Yeah, so maybe one more addition to it, Labview, I just installed because it's so fresh. I just installed from the VI package manager. If you look for InstaCoverage, then you will see the latest version 330. Just installed it in the morning from the public database. Obviously we had internal packages. And yeah, I don't want to give you a tutorial on InstaCoverage. Basically, it's Labview as you know it, and it's integrated. For example, I run all tests. You see the facelifted NXG styled UI. You can. This is the Pro version. So if a diagram is not covered, then it will be listed. And if you double click on it, it's on my other screen, then it will jump to the uncovered diagram. You can generate reports, HTML, XML, and you have InstaCoverage is the configuration extension. So basically, it's the test suite configuration part of InstaCoverage, which you have per test. And
So
then you have
I
a screen
noticed
window where you
something
can
on your test
configure your
results.
test.
It used to be that you either had 0 or 100%, and now you had a 93% in one of those results.
Yeah. So we added it versions ago, but yes, it used to be like that we didn't have the
other
exact
thing I
figure. Now
wanted to
we
bring up,
have.
I bring this up on the Labview Graphical Programming 5th edition, that companies that are in regulatory environments were forced to use unit test framework from an I because it was ISO certified company.
Yeah.
And I believe you were like, when I was doing my last revisions to the book, you sent me the email, Fab, we are ISO certified now. So
Yeah, we are. So if it was a burden for certain users, it should not be.
and, as far as I know, unit test framework
So
is not
that.
migrating to NXG. So far the solution for NXG is InstaCoverage, right? So far
Sorry, can you repeat?
the solution for or the replacement for unit test framework on NXG would be InstaCoverage, right? There's no unit test framework for it.
Yeah, and I don't know of any other unit testing tool
Yeah.
for NXG. Yeah. Thanks for the addition. And we have another question. How is the I/O handled when testing? Putting data from a file, receiving it from a device or by the network? Yeah, so basically, another good question. Thank you. So you see here, basically, wait a sec. So Insta Coverage, every time you generate a test, this is not to be mixed with automatic test generation, but still Insta Coverage help you with generating a template, which will basically in the middle you have the VI and the test. It will generate a setup and the tear down VI, and at least the Pro version will automatically, so it will run some basic code analysis. It will learn what the inputs of the VI and the tests are, what the outputs are, and it will automatically connect the inputs and outputs with the setup and the tear down VI. And basically, if you click on the setup VI, you can do whatever you want to set up the test, and this can even be an IO operation. So you can stub, mock, and all those things that you know from unit testing. You have to do it, basically. You have to make sure that the IOs are set up and used.
Which goes to a whole other discussion that as soon as you start adding network and databases and IO, it's really more integration testing. But we're not going to go there. That's another whole presentation.
That's another,
so it's
other big topic.
It's 3 minutes you have 3 more minutes. And then in 10 minutes more, we're going to have the closing session. So in about 13 minutes, in 12 minutes, we're going to have the closing session at the main stage. But we're leaving the platform open for at least another 2 or 3 hours. I doubt that the organizers are going to stay around for another 2 or 3 hours. But if you guys want to continue the discussions, you can either stay here because there's no other presentation after this. Feel free to use the expo, the networking, everything else. Yeah, Chris Stryker saying we're going to leave it open for 2 more hours. Thank you so much, Peter. It was very interesting. I am definitely going to have to watch the recording when I'm more awake. but the parts that I could catch,
Thank you.
It was very interesting.